Okay, 81, this is where things are getting a little bit tricky. It's the epsilon delta definition of the limit. And they want us to prove that this limit here, let me point this out to you, is in fact equal to 4. And then, certainly if we were just doing this, we'd say, oh, the limit as x goes to 1, 6x minus 2. And you say, oh, the limit laws, you just plug them in, you get 6 minus 2, which is 4. But they're asking you to prove it. All right, not use a limit law, prove it. So we're going to look through at the definition of this epsilon delta definition. It says let f of x be defined for all x not equal to a over an open interval containing a. Now just thinking about that, we're saying that there's some function f, there's some interval that's open, and this function f is contained in that interval, but not necessarily at a. All right? And they said let L be a real number so that that's the limit value. All right? Then it goes on to say, if for every epsilon there exists a delta greater than 0 such that the difference between x and a, that's the absolute value of it, is less than delta but greater than 0. That means x does not equal a. Then f of x minus L, the distance between those two, will be less than epsilon. All right? Now, it's a mouthful to read that. It really is. But the structure, and I like what Blackpen does. He kind of simplifies it into 4 distinct steps. And let's write those steps down for you. And for the most part, for a linear problem, they're pretty simple. For nonlinear problems, they get a little more complicated. But you're going to be given this. So he says, write down given that. That's pretty simple. The next thing is you got to choose the delta. Now, choosing the delta is really almost the entire part of the problem. I don't know what the delta is. But what you're going to do now is you're going to write down what they said. Let's write it down. You're going to write down the absolute value of x minus, well, what's the a? The a is 1, less than delta. You do not want the x to be equal to 1, though. So that means that this is going to be strictly above the 0. All right? And then what you got to do, we just did this part over here, suppose. We just wrote that down. We need to check. Let's write that down. What do we need to check? We need to check this second part. We're going to check it now. Well, what's f of x? F of x is 6x minus 2. What's the L? We believe the L to be 4. Right? Now, I'm going to simplify this thing, and this is going to be the absolute value of 6x minus 6. I'm going to factor that, and what do you get over there? You would get 6 times the absolute value of x minus 1. Well, what do I know about that? I know something over here. I know this is equal to, not equal, I'm sorry, I shouldn't say that. That this, in fact, will be less than 6 times, well, x minus 1 delta, right? Now, where's that coming from? Right over here. Now, the question is, I got to choose this delta. So this would be actually the same thing as the epsilon. Where's that coming from? Right over here. So let's do that. 6. What's the delta going to be? It's going to be epsilon over 6. All right, so what do I got to do now? I got to go back up to that second step and write that down now. So what's the delta going to be equal to? Epsilon over 6. Now again, I want to point out that took work to get to that, right? I didn't see that initially. I had to do the work to get there. For linear problems, it's pretty straightforward though. All right, so epsilon over 6, it's a positive number, so I do write down greater than 0 over here. How do we do this one? We went to the last step to do it. That's how we got it. All right, thank you.